one of the more notable ones is Streptococcus pneumoniae. Okay, we've talked about Streptococcus in different parts of the class. All right. This one often has a high mortality rate, like 25%, let's say. Okay, for very young or very old who get this serious cases of pneumonia. There's another one though called Mycoplasma pneumonia, and this goes by different names. It's called walking pneumonia. It has that name because sometimes the symptoms are mild. It's called primary atypical pneumonia. Okay. There's another one called Klebsiella pneumonia. And there are other bacteria that can cause this. Haemophilus influenzae is one. Staphylococcus aureus is another. Staph aureus is a bacteria that you'll find can invade many different parts of the body. Remember, it's a very common one that's found on your skin, found on your body. All right. Probably about 25% of you have it in your nose right now. Okay. So it's very easy to see how that can affect different parts of the body. All right. So here's Streptococcus pneumonia. Just to give you an example. All right. And so remember, we talked in different parts of the course about this capsule. So here's a picture of the capsule. This is what it typically looks like. It comes as a paired cocci, Diplococcus. In fact, the old name for this is Diplococcus pneumonia because it has very characteristic morphology. All right, so let's focus on this one since this one causes serious problems. I mentioned this has a split capsule, resists phagocytosis. This causes pneumococcal pneumonia. So this is a clinical name that you often see with this bacteria. Right, pneumococcal. Just to reference to its shape, what it causes. The reason why this is such a serious pathogen is that it can lead to serious complications. So one is septicemia, sepsis. Okay. It can also cause endocarditis, so it can affect the heart valves. Also can lead to meningitis. Right, so this is one of several different pathogens that can cause meningitis. Right? So this is the reason why we're always on the alert for this type of bacteria. All right, I want to spend some time talking about another pathogen. This is a pretty serious pathogen as well. And this is actually an example of a notifiable disease. Right, so if a disease is notifiable, what does that mean?
It has to be reported.
Right, it has to be reported. Right, it has to be reported to U.S. Public Health. Right? And the reason why is that this one is a very major cause. It's a very important cause, a very major cause of death. So let me go through that. So first of all, just to go through some of the statistics about TB. Worldwide, about a third of the world's population, a third of the global population is actually infected with TB. Okay? So that's an incredible number of individuals. Most of the cases, as you might imagine, aren't here. Okay? But in developing parts of the world, there are many cases of TB. 8 million new cases per year, 2 million deaths per year worldwide. Right, so this is the leading cause of death by bacteria. Okay? Also, as far as individuals with HIV, TB turns out to be a leading killer of people infected with HIV. So that's a serious complication of someone who has HIV. So whenever and we do hear about outbreaks of TB, even in Sacramento. There's a TB clinic that monitors that and treats cases of that. And so this is something we're always on the watch for. So what I want to do is go through the disease course with you. What happens during TB? Remember that it's caused by a bacteria. It's called Mycobacterium tuberculosis. Okay. And the way that it spreads is by aerosol. So this could be from an actively infected individual. It could even be from dust particles. Okay. So last night, last night, another class I was teaching there, some students in a presentation about the kinds of microbes that exist in college classrooms. Okay, and so there are scientists who actually looked around like a room and swabbed different areas, kind of like what you would do. So where do most of the microbes exist? What part of this, if you're looking at this room, surveying this room, where would you find most of the microbes? Would it be on the air, chair, desk? Where would it be? What parts? If you were to point somewhere in this room, where would it be? It's actually here on the floor. Okay, all right, on the floor. All right. So, and one thing, the reason why is that there are particulates on the floor, and they're actually microscopic particulates, and so lots of microbes are caught in that, and so this is why dust particles are, it's just dust, but they're actually a very good reservoir for microbes, right? So when you're sweeping up the floor, you can actually be spraying up all this bacteria that you get exposed to. So we get exposed by aerosol. The bacteria get into our body, right? And this is just through breathing, and then they go into our lower lungs. Okay. So there's an illustration that shows this. This is from your book. And so here, if you breathe in those droplets, breathe in that aerosol, the bacteria go down into your lungs. Okay. Then they can start to multiply. Now what happens, and this is because of our host defenses, this activates the macrophages, and they'll do phagocytosis and take up the bacteria, right? So usually with other bacteria, that's kind of like the end of the story. Right? Those bacteria are broken down during phagocytosis. However, mycobacteria tuberculosis is different. What happens is that bacteria can actually survive inside the macrophage. You can actually use that as kind of a decoy or camouflage in order to keep on reproducing. So what happens is here's the macrophage that takes up the bacteria, but now remember the bacteria is able to survive. Okay. Right. So does everyone remember what part of the macrophage is responsible for breaking down the bacteria? What's the name of the organelle? Use the L. Lysosome, yes, it's lysosome. Okay. Right. So, and then it fuses with the phagosome to become what? A phagolysosome. Right. So a phagolysosome. Okay. Right. So what happens is that Mycobacterium tuberculosis has the ability to prevent it from being taken up into a phagolysosome. Okay, right. So what happens is that it's able to avoid getting exposed to the lysosome, so it just hangs out inside the macrophage, and then begins to multiply. So as the macrophages take up the bacteria, the bacteria just simply multiply. And when the macrophages die, the bacteria still remain, and they form this kind of mass, right? Which consists of the live bacteria and the dead macrophages. Right? So this is what accumulates inside the lungs. And this is called a tubercle. Over time, the structure hardens up, becomes a tubercle, and inside are the live bacteria. Now what happens during this phase, right, the bacteria, they're still viable, they're still alive, but they usually go dormant. Right? So their metabolism slows down, they're not actively multiplying at high speed, at high rate. Okay? But they're there and they're viable. Right? So someone who's been exposed with a primary infection, so we're talking about primary infection, has these tubercles inside their lungs which contain live, although dormant bacteria. Okay? Now, what happens is that when this infection becomes active, what happens is that the bacteria get reactivated. And so this becomes secondary tuberculosis. So this usually occurs when these tubercles break. So here we have a tubercle. Okay, so here it's kind of a hardened structure, but it can break. And how it can break is simply by like coughing. That can break it. Okay. And what happens is when this tubercle is ruptured, that releases all that bacteria out into the lungs, and then they can spread. Right, so this is where tuberculosis happens. And the bacteria, in the process of spreading, they can cause serious damage to the lungs. Right? In fact, they can destroy the lungs. Right, so that's what happens with TB. Now here's an example of a case of tuberculosis. So here's part of the lung, right? This is uninfected, but here you can see tubercles inside the lung, right? And so in an X-ray, this is one reason why the physician thinks you might have tuberculosis, why you need to get a chest X-ray. What they're looking for are these structures, these tubercles, okay, that form inside the lungs. So they appear whitish in the lungs. Okay. All right, any questions about this?
I've heard that even with a strep pneumonia, your lungs, it's very difficult to recover, and they're never at the same capacity
Right.
as they were before. So even a strep pneumonia would, there would be not necessarily a tubercle, but some sort of blockage.
Yeah, so just because we're dealing with pneumonia, so we're dealing with inflammation. So inflammation is kind of like a dual-edged sword. So it could work against your own tissues, right? The process of trying to destroy bacteria could destroy your own tissue. So that very well happens in these cases. All right, so just to let you know about